Hello everyone. In this video, we will be solving system of equations involving word problems. This is the third part. I will put the link of the first and second part in the description box below. Let's take this example right here. A passenger jet plane travels at an average speed of 600 miles per hour with the wind. On the return trip, the average speed of the plane is 550 miles per hour while flying against the wind. Find the speed of the wind and the speed of the plane in still air. We have methods in order that we can solve this kind of word problems. The first step is to define the variables. So as you can see here, on the last statement, we are asked to determine the speed of the wind and the speed of the plane in still air. So in our first step, we need to define the variables. Okay, so I've defined the variable. I let x equal to the speed of the plane in still air and y is the speed of the wind. Now let's move on to the second step. The second step is to set up the system of equation and eliminate one of the variables and solve for the other variable. So I'm just going to label this as step 2 right here. We remember that since we're involving speed here, we remember that the formula that involves speed . Okay, so the formula that we're going to use would be speed times time is equal to distance. So for those who have taken physics, you may have used this in your physics class. Or those who have taken science, then you might have used this equation in solving for speed or in solving for distance in this case. So we have two cases that we have here. The first case is with the wind, and the other case is against the wind. So we're going to create a table here. Okay, so I created the table for the two cases. The first one is with the wind and the other one is against the wind. Since this 600 miles per hour is with the wind, so we're going to use this first row right here with the wind. So this 600 miles per hour means in 1 hour, the plane has traveled 600 miles. So then we can go ahead and say this is equal to 600. The distance is 600. And then the time right here is 1 hour. And we want to know the speed of both the plane and the wind. So in this case right here, since this is with the wind, so the plane is flying with the wind. This means that the plane has been pushed by the wind since they were going in the same direction. So then we can go ahead and say the speed of the plane plus the speed of the wind, y, because again they were going in the same direction since this is with the wind. So the plane was actually pushed a little bit because the plane was actually moving with the wind. So that's our first equation. The second equation is against the wind. So it says here, on a return trip, the average speed of the plane is 550 miles per hour while flying against the wind. So that is 550 miles per hour means in 1 hour it's 550 miles. So I can go ahead and write 550 here. And then that's for 1 hour. Again, this is by the way multiplication. So the dot here represents multiplication. And then since this is against the wind, so others are going to say, why is it that it was a little slower to get back than to go with the wind? Because if we say against the wind was actually flowing against the plane. So the plane was slowed down a little bit because the wind was moving against the plane. So then we can go ahead and say that the speed of the plane minus the speed of the wind, because the wind was against the plane. So this is our second equation. So if it's against the wind, it's going to be a minus. If it's with the wind, it's going to be an addition. So then we can go ahead and say that we already have set up the two equations here. So the first equation would come out to be, so this is how the first equation is going to look like. So that is x plus y, and then remember that is 1 right there, is equal to 600. And then the other equation, the second equation would be x x minus y, and then that times 1, that is equal to 550. So then from here, we can go ahead and distribute the 1. Since a number or an expression multiplied by 1 is the same number or the same expression, so then we can go ahead and simplify this as here. So I'm just going to write it up here. So that would be x plus y, since I multiply the 1 to each of them, and then that is equal to 600. And then the other equation would be 1 and x, and then 1 multiplied by negative y is just the same thing. This expression right here, again, any number or any expression multiplied by 1 is the same number or the same expression. So that would be x minus y equals 550. So then from here, we can go ahead and ready to solve one of the variables. Since both of the x's are equal, I can go ahead and subtract these two equations together. So that if we subtract this, that would be x minus x is 0. So that means we can cross that out. We have a positive y minus negative y is a positive 2y. And that is equal to 600 minus 550 is 50. So then we go ahead and divide both sides by 2 so that we can solve for y. So then we are left with y is equal to 25. And the unit that we have here would be miles per hour. And this is the speed of the wind, since this is our y. So I'm just going to label this as the speed of the wind. Okay, now we're ready to move on to step 3. In step 3, we're asked to plug in the value that we solved from step 2 to any of the original equations. So to any of these equations right here to solve for the other variables. I'm just going to go ahead and write step 3 right here. So again, we can use any of these two. It doesn't really matter. So I'll use the first one right here. So we have x plus y is equal to 600. And then we plug in the value since our y was already 25. So we plug it in here. So that would come out x plus parentheses is equal to 600. And then the one that we put into parentheses would be the y, which is 25. So I'll put in the 25 there. So this would come out x plus 25 is equal to 600. I want to solve for x. So then I go ahead and subtract both sides by 25. So minus 25 and minus 25. And so we are left with x is equal to, that's going to be 575. So the unit that we're going to have here would be miles per hour. And this is the speed of the plane, which is represented as variable x. So I'm just going to label this as speed of the plane. Okay, so x is the speed of the plane in still air. And we have solved this problem. We already have determined the speed of the wind and then the speed of the plane in still air. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!